Okay, so I'll begin so we stay on time. Welcome everybody to today's space showcase from the Deep Tech Showcase. Today we're gonna have some great pitches starting at 1:20 Eastern and then concluding at around 3. But before that, we just have some opening remarks and we're gonna introduce the panel. So just to talk a little bit about who we are, Deep Tech Showcase. Our vision is to bring deep tech to market by leveraging the power of the community. So we have an ecosystem for deep tech only. We have startups, government and corporate tech scouts, and investors who are all seeking to connect with each other for various reasons. Investors, of course, are looking for deal flow. Corporate tech scouts looking for cool technologies that they could potentially integrate into their company or invest in or potentially purchase. And government tech scouts are looking for innovative solutions to help solve some of their challenges. So anchoring this ecosystem, we have monthly showcase events by industry theme. This month's theme, of course, is space, but we have other themes, such as last month, we had autonomous systems. Next month, we actually have two events. One of them is a joint event with GC Ventures America and Decarbonization Technologies. And we also have a Future of Computing event. But we have many different events throughout the year, typically at the end of the month. And at these events, deep tech startups pitch to a panel and audience of tech scouts from government and corporations, as well as to investors. Apart from the events, we also do guided introductions. And stakeholders turn to us to scout specific technologies, like, for example, space technology. So in between the events, we send company profiles to these stakeholders if those profiles could be relevant to what those stakeholders are looking for. And if there is a mutual interest, we make an introduction and business often follows. As mentioned, these are our upcoming showcase events. We have the Decarbonization Showcase on November 14th, which is a joint event with GC Ventures. And we have a Future of Computing Showcase on November 29th. So we'd love to see you all there. Now, a word from Eagle Point Funding. We have Yoav Sadan, who's a Director of Business Development at Eagle Point Funding. Eagle Point Funding is the parent company, if you will, of Deep Tech Showcase. And Yoav will just like to give a few words about what they could offer.
So, hi, everybody. It's pretty clear that I'm the least interesting person on this panel today. And we're here to see great companies and hear great panelists. So I'm going to be making this quick and to the point. Our job is to help you find, manage, write, apply, and win non-dilutive funding opportunities. We're pretty good at it. Our companies win a good amount in 9 months, and they win a whole lot in 18 months. So hop on the call, scan the QR code, email me at yov@eaglepointfunding, and we'll find at least some opportunities that are fit for you. And if not, we'll go our separate rates. But it's fun to work with us. More amusing usually on a one-to-one call. And it's really great seeing some of the companies that we've been working with pitching here today. And that's it. We signed a team working with you. And I will now leave the stage and let better companies and more interesting people than me take the stage. Really looking for a really awesome event. And I'm putting in the chat my email and Calendly. And that's it. Let's have a great event, everybody.
All right, thank you so much, Yoav, and don't sell yourself short. You are extremely interesting. And that's another reason why you should book a call with him. Our event will go as follows. We have splitting this in 2 sessions. Our first session, we have some great companies like Edmund Scientific, Diva Wireless, BitRip, and Sereniasat pitching. And in our second session, which is our second hour of the event, we have Precursor SPC, Accelerium, Intergalactic, and we will finish it off with Kahan Space. So here are actually the panelists for session 1. But what I'm going to do actually now is I'll stop sharing screen and I'll have you all introduce yourselves. So I'll start with the first person I see on my screen, which is Baharet.
Good afternoon, everyone. Thank you. Thank you, Brian, for inviting me again. I'm excited to be here. I'm Bahar Ahad Saeed, Technology Scouting Director for BAE Systems. As it sounds, I'm a technology scout looking for technology and small businesses and startups to bring into our internal folks' attention for collaboration and partnerships opportunities. We have several focus areas within BAE System. We are a huge defense company. And if you are interested in connecting with us, I would be the first step to connect to. And excited to hear from you guys today.
Awesome. Excited to have you with us. Next, we have Gerald Wang.
Thanks very much. So hi, this is Gerald Wang. So I'm the corporate venture from the PTTGC. So PTTGC is a petrochemical company based in Thailand, and so we make polymers. So we're very interested in space tech from two major angles. One is how the advanced materials, especially advanced polymers, can serve the space tech use cases. Second one is how space tech, especially in space manufacturing, how this can facilitate the material R&D. So these are the two major angles I'm bringing here. So look forward to knowing more about the startups and have further conversation there. Thank you.
Awesome. Really happy to have you, and also really happy to have Gerald's colleague, Lisa. Do you want to introduce yourself?
Hi, Lisa Dufresne again. We're from GC Ventures. We are co-sponsoring the decarbonization showcase next month. We're the corporate venture team, as Gerald said, of PTTGC, or GC for short, which is Global Chemical. Our team is actually based in Boston and tend to look at advanced materials and decarb technologies. Thanks.
Awesome. So happy to have you with us. Up next, we have Benjamin Zaytoun.
Hey everybody, thanks for the invite today. I'm a partner at Starburst Ventures. I invest in new distribution of technology, and we historically have a really good expand in aerospace and space tech.
Awesome. So happy to have you with us. Next, I see John Richmond.
Good afternoon. John Richmond with Lockheed Martin Ventures, investor on behalf of our space portfolio. I cover cybersecurity, common 5G, sensor technologies, and quantum technologies outside of our space investments. And Lockheed Martin Ventures invests in virtually anything that has to do with aerospace and defense. Nice to meet you.
Awesome. Really happy to have you with us. Up next, I see Joe Epstein.
Hi, Joe Epstein, also from Lockheed Martin Space. My role is to find emerging technology from inorganic sources. I own the SBIR portfolio for space. I also deal with other transaction authority applications, ventures, as well as university engagements. I look for early stage technology, often at the component level, and work a lot with John.
So up next, I
think my internet might be a bit choppy, so let me know if I break up here. But I'm Gus. I'm at Boost VC, where we back early stage deep tech companies, and I'm a principal there. We're a $200 million total under management, $70 million fund 3, and we just love all things early stage deep tech, everything from aerospace to bio and health to AI and robotics, etc.
Awesome. Thanks for joining. Up next, I have Craig McClellan.
Thanks, Brian. So Craig McClelland with the Federal Economic Development Agency for Southern Ontario, so up in Canada. I work in the defense sector, helping to connect local SMEs and researchers and other stakeholders here in Canada with folks like Joe and John at Lockheed and other companies with defense interests in Canada, and really leveraging Canadian defense procurements to help make connections back into opportunities here in the country. And often a lot of times that means identifying these emerging technologies and then really understanding what's of interest to this group of people that we have around the virtual table today. So thanks again for letting me participate and learn a little bit more. We, if any of these companies happen to have Canadian operations, there's a bunch of funding available that I could talk to them about as well. So we'll see where this goes.
Awesome. Thank you so much for joining us. Up next, we have Tim Jones.
Hey, Tim Jones, located in Colorado. Part of a deep tech incubator that's been around for 25 years, as well as more recently venture capital funds, investing both here in the U.S. and in Israel. That's me.
Awesome. Thank you for joining. Up next, I have on my screen Dan Saha.
Hi, I'm Dan, and I'm working for BDF Ventures. We're going to have a deep tech fund soon. But more importantly, I used to work with Alumni Ventures, and I act as a technology scout for them for space tech companies.
Awesome. So happy to have you with us. Up next, I see Martina Dimosca.
Hi all. So I am the local lead, which is the main organizer at two space events called the NASA Spaces Challenge out of Mountain View at NASA Ames Research Center and Cleveland and NASA Glenn Research Center. What we do is we encourage young founders and novel entrepreneurs to join the hackathon, solve the problems with NASA data, and then we have a lot of founders, business angels, and venture capitalists visit when they're pitching to potentially grow their product. So it's a lot of first stage investments as well, a bit of bootstrapping. So that's what we're doing.
Awesome. Thanks for joining us. Up next, I see Jefferson Mitchell.
Hi, thanks again for having me here. First time on the panel. Major Jeff Mitchell is currently at Space Delta 13, focused on education. However, across the Space Force, I'm plugged into the overall accelerators and Space Force innovation ecosphere. So happy to represent and help some of these companies perhaps get some non-dilutive funding and opportunities within DoD. So thanks.
Awesome. Thank you so much for joining us. And also, I see Adam Shura.
Hey, thanks for the opportunity. I always feel dumb showing up to events like this because everybody is so amazing. My background is 2nd Air Force, innovations and future environments. As you can see with the beard thing I got going, I'm on the retirement process, but really looking to take things from one level to the next, right, in the corporate and or the innovation realm here within the DoD.
Awesome. Thanks for joining us. Up next, I see Lena McDonald.
Hi, thanks. Yeah, I'm Lena McDonald. I'm with Outsiders Fund. We're a VC firm based in New York. We're relatively generalist, but my background's in space. I spent a while working on the lunar landing programs, and so I spent a bunch of time looking at space companies. We're seed and Series A and have about 150 AUM at the moment.
Awesome. Thank you so much for joining. Up next, I see. Sure, thank you. Up next, I see Peter Ruiz. Oh, you might have. Yeah, Peter actually might not be able to speak at the moment.
I'm here. Can you hear me? I lost some bandwidth. Sorry. I turned off the video just because I'm at the airport. But so I'm with Invest Puerto Rico. It's split time between Puerto Rico and California, believe it or not. But I'm focused more on the aerospace and defense and island. I know most people view it as which is U.S. territory, but most people view it for beaches and palm trees. But half of the GDP is manufacturing, a lot of aerospace, a lot of pharmaceutical, a lot of medical device, and that's kind of my focus. And we have everyone from Honeywell's Aerospace's aftermarkets HQ to Collins and Pratt & Whitney, but also working with a ton of new younger companies, whether it's an AI or lasers or anything else. Maxar Technologies just purchased an AI software development company, and we just keep growing in the aerospace field.
Awesome. Thank you so much, Peter, for joining and making the effort to join us today. Next, I see Rudy Baisa.
Hey guys, how you doing? Name's Rudy Baisa. I'm based out of Edwards Air Force Base, heavily focused on innovation and in the test and development side for aircraft maintenance. So, but not only just that, but also focus in AI, ML, and many others that I can interconnect. So we got a vast network of folks. So I do see Adam Scher there. So hello from the other side. Good to see you again. But that's what we got to offer. Over.
Awesome.
Good to see you too, my brother.
I'm glad we could also help the showcase could help make some reunions. So happy about that. I'm happy that you're all with us. So we still have people on the panel, believe it or not, everybody. We have a few more. We're almost done getting through the intros. So up next, I see Ryan Cross.
Hey, good afternoon, everybody. Thank you. Ryan Cross here with the 724th Special Tactics Group, Air Force Special Operations Command. I am their liaison officer up here in DC, the overall National Capital Region. My main focus here is to integrate, partner with industry and other U.S. government agencies, look for innovative and emerging tech to support the special operations warfighter from non-kinetic electronic warfare, but other technology-specific advantage points as well from SUAS, space, kinetics as well. So thank you.
Sure. Thank you so much for joining. Up next, we have Mark Rudzinski.
Hi, everybody. I'm with the strategic sourcing team at General Dynamics Mission Systems. Mission Systems is one of the 10 operating companies under General Dynamics corporate banner. We don't make the tanks or the battleships or the submarines, but we make a lot of the technology that goes in them to enable mission operations. We're interested in just about anything space related, sensors, materials, networking. We're also interested in all the usual suspects: quantum, AI, ML, materials, all that stuff. Thank you.
Sure. Thank you so much for joining us, Mark. Up next, we have Murray Chapman.
Hello, Murray Chapman. I work for an AFSOC group and glad to be with you today.
Sure. Thank you so much for joining us. And last but not least, we have Andrew Boudet. Or maybe Andrew doesn't have audio. All right. So while Andrew is sorting that out, yeah, his mic issues. Okay, that's fine, Andrew. If you want, you could write a little bit about yourself in the chat. And thank you so much for joining us. But now we'll finally get to what everybody here is for, which is the company presentations. So the way this will work is that the companies will pitch for 5 minutes and then they'll field questions from the panelists for 5 minutes. Panelists, if you have a question, just raise your hand in Zoom, and then I will call on you to ask the questions as you appear, first come, first serve, basically, for the hand raising. And with that, we will have our first company, Edmund Scientific, pitching. I believe we have John here from Edmund Scientific, who will be giving the pitch.
Peter's going to give the pitch.
Yeah. Thank you, John. Thank you, Brian.
Sure.
Yeah, and I'll go ahead and ask to share screen here. All right, everybody can see my screen okay?
Yes.
Okay, all right, thank you very much. Yeah, again, thank you to our friends at Eagle Point and to all the panelists. We do appreciate your time today. I'll try to keep this short. I have a tendency sometimes to be a bit verbose, but I'll see what we can do. Historically speaking, the idea of free space optical or laser communications has been with us now for decades, actually since the 1970s. But it runs into a number of physics problems, specifically having to do with the atmosphere, the attenuation of clouds, precipitation, and of course, turbulence. So last year, and I'll get into the details a little bit later, Edmunds conducted some scientific testing And we believe that we actually have a solution to defeat these atmospheric effects with a very, very unique and innovative technology. With me, for some reason, the system's not responding. There we go. With what we call structured light. And for those of you who are familiar with communications, the structured light is acts as though a waveguide. We transmit a laser signal, a dual laser signal, one through the atmosphere, that provides basically a virtual waveguide to allow a second laser signal that's carrying the information to connect in a point-to-point configuration. So again, as the illustration shows, a vortical channel 1 produces a shock wave which clears the particulates and the water density from the path, and the second channel is used for the communications payloads. We believe that this system can be incorporated into a number of existing platforms which are under development by various companies. And as I say, as this being a bit of a holy grail is being pursued by a number of companies all over the world. As mentioned, we did a successful chamber testing in a cloud chamber on a laboratory and brought the technology to what we believe is a technology readiness level number 3. And we're looking for investment specifically to take this to TRL 6 and beyond. The illustration shows that, again, if you look at the bottom center, the cloud chamber, where we were actually effectively able to create that so-called waveguide in space to allow the information signal to pass through, are relatively undisturbed and unattenuated. And again, just to underscore the applications here, even though we have pursued this with the intent of satellite to ground communications, this technology can easily be adapted for air-to-ground, air-to-space, as well as air-to-air communications. The big advantages here being 10 to 100 times higher duplex transfer speeds. And in addition to that, there is an inherent protection here and security, because unlike RF signals, which are broadcast out in all directions, obviously the energy and the communication content within the laser is highly focused in a point-to-point configuration. And it's also important to note that this is a dual-use technology. It can be deployed for both military and for commercial satellite systems. We have been actually very, very, very busy as of late. As you can see, we've been trying to generate a lot of traction, a little bit of stop and go, admittedly, but we've been aggressively pursuing SBIRs through the National Science Foundation. We've also submitted a phase 1 AFWERX SBIR back in September. We are currently proposing a direct to phase 2 SBIR, which is due a little bit later on in November. And we are also developing paths through the Space Development Agency. We are also engaging satellite communication companies, existing manufacturers with an interest in optics, and gaining traction, some traction through them. So essentially, our ask here is twofold. For those of you in uniform, we are looking for an end user sponsor for our AFWERX direct to phase 2 MOU, which as of last Tuesday is up and underway. And for those of you representing the investment community, we are looking for additional funds to take our FSO to the next level, TRL 6 and beyond. Again, our foundational team, John Patali, who's joining here with us today. myself, Jim Mazie is our principal engineer, and for our principal investigator for the SBIRs will be Musa Noam, who has the expertise and has been conducting the tests to date. He's got an excellent background and 100% of our faith and confidence. So with that, I will stop talking and open it up to any questions or comments from the group.
Sure. Thank you so much, Peter. And with that, we'll open the floor to questions. So if anybody has questions, you can raise your hand and we'll call on you, or you could just jump in. Yes, Ryan.
Hey, just curious if you guys have done any testing with ground-to-ground comms with this technology. Thanks.
No, not as of yet, but that is part of our D2P2 test plan, is to take some existing hardware systems, apply our technology, and that actually is the first phase. We will be conducting what we can call outdoor range testing and doing that at different lengths. One of the potential end users that we were talking about, talking to about the MOU, is exactly that. It's a line of sight test over a distance of approximately 2 kilometers to connect 2 data centers together.
Okay, great. No, that sounds great. Definitely interested in the outcome of that test, and really appreciate it. Thank you.
Sure. Anybody else have any questions? We have time for one more.
Yeah, just I guess this Major Mitchell, just curious if you worked with Air Force Research Lab at all.
Well, we haven't worked with them, but we certainly have applied to them. As I say, there was an open topic SBIR, which we got in last month, and we're hoping to hear back on that. Actually, I think it closed on the 28th of September, and then here on the 24th of October, another AFWERX direct to phase 2 a window opened up. So yeah, we're actively looking at AFWERX as probably, shall we say, our early adopter.
Yeah, did you get any MOUs signed from any units or?
No, not as of yet. We are talking to 2 different units right now, but again, because of various activities around the world, they've been a bit preoccupied. So we are looking for any possible alternatives, and again, those we encourage those. As you can see, our contact information is here. You can also reach EPF for that. We encourage you to reach out to us, and we'll keep you abreast. Even if we're not, even if you're not sponsoring us, we'll certainly keep you abreast of where we are in the process and what our next steps are. Yeah. Again, when I looked at this, and again looking at your background there, Jefferson. Yeah, obviously this speaks to the SDA Tranche 2. There have been a couple of there's a couple of companies, and I think actually it was either announced this morning or will be announced tomorrow. A Tranche 2 from the Space Development Agency will be awarded. And again, our technology is not in competition with that. As a matter of fact, it could be added on to any of those Tranche 2 vendor platforms.
Sounds great. Yeah, it looks like you're making all the things you should be working on for our side. So thank you for bringing the time.
My pleasure. Thank you.
All right, and that's it for time. So thank you so much, Peter. Peter, if you just want to put down in the chat also some of your contact info so that people can see it once you're done sharing screen, and then they can reach out to you if they would like. And with that, sure, thanks. And with that, we will move on to our next presenting company, which is Jiva Wireless, and we have Aaron Parks presenting.
Hey, y'all. Everybody seeing the screen okay?
Yes.
All right, awesome. Thanks, Brian. Appreciate the opportunity to kind of clue you guys into what Jiva is doing. I'm Aaron Parks, CEO here at Jiva. We're located in downtown Seattle, Washington. So Jiva is providing a new tool in the arsenal of hardware engineers and product designers, which is a new way of communicating wirelessly at extremely low power. So I'm here today just to kind of get a sense of whether there's interest in your respective communities in the tech that we have to offer, and certainly interested in any ideas that bounce back. So whether it's a desire to replace this bundle of cables and a flight test instrumentation application with a much simpler wireless solution, whether it's an interest in understanding the current state of machine health across a complex piece of equipment or on the factory floor, or an interest in understanding location and environmental condition of palletized equipment. There's kind of a common pain point when trying to move from wired to wireless solutions today. And this is the size, cost, and hassle of batteries and battery replacement. So what's the problem? Radios consume a lot of energy. So the radios that enable wireless connectivity consume typically about 85 to 95% of a typical wireless sensor node's power budget. So that just goes to moving data across the wireless link. And this can be particularly problematic in high bandwidth applications like the ones that are outlined here. So conventional wireless systems can have either long battery life or can move a lot of data, but really can't do both. So, if you think about conventional wireless technologies and also some other sort of, newcomer tech, these are all conventional radios in the sense that they all operate in a similar way. They, take energy from a battery, convert it to a radio signal, and they push it out into the environment. They all fall somewhere along this trade-off line between, moving a lot of data and achieving a long battery life. Getting over this trade-off line and being able to move more data for less power is kind of an uncharted opportunity, and that's actually what Jiva enables. So how do we do this? Conventional radio, again, is a bit like a flashlight. You're taking energy from that battery, convert it to a radio signal, amplify it, modulate it with the information you want to send, and you're pushing that energy out. So it's power intensive, it's complex, it's actually fairly expensive to do, requires fairly large silicon area on a chip to do that. Turns out there's actually another way to communicate, which is backscatter. So backscatter is reflecting energy to communicate. So it's kind of like using a signal mirror. And this is what Jiva Tech does. So the net result of this is you can move more data for less power. And because of the reduced silicon area requirements and reduced battery requirements at scale, this can also be cheaper and smaller. So to make backscatter work, you need to have some type of base station or access point that is going to support it. So that base station is going to send out what we call an illumination signal. This is no free lunch, right? What we're doing here is we're moving the requirement to generate the radio signal to the base station, and we're saying that this backscatter capable device is simply going to reflect that radio signal. So the secret sauce of Jiva is that we are able to actually transmit conventional radio protocols using this process. So we can send things like Bluetooth, LoRa, flavor of Zigbee. We can actually send Wi-Fi signals. So we can actually transmit things that look like, and for all intents and purposes, can be used as these conventional radio protocols, but they can be generated through just simply reflections. So what does an implementation look like? In a consumer device, in a consumer ecosystem, an implementation looks something like this. We could take a smartphone, repurpose two of the many existing radios that are on that smartphone. One of them provides the illumination signal, and the other one is going to receive the resulting reflected packet. So the battery life and power requirements of something like, a stylus for an iPad are almost entirely driven by wireless connectivity. So this can have a huge impact. And really in aerospace applications, we see a number of interesting use cases. So here are a few examples. The theme of all of these, again, is that benefit of getting more data for less power. So picture wireless flight test instrumentation. This would reduce the need for cable runs, both in ground testing and flight testing scenarios, because we can push lots more data over a much longer lifetime. We also have ability to get wired equivalent time synchronization post a project that we did along with NASA. In machine health sensing, we can, again, move lots more data for the same battery life, which removes a capability limitation and kind of lets us stream sensor readings continuously. So removing kind of some of the conventional, hurdles that folks will face as they move to wireless. And really in long-lived asset monitoring, tags, for monitoring parts as they move through the supply chain or other assets as they move through the supply chain. We can get low cost, long-lived sensor tags on equipment that can do things like environmental condition monitoring and alerts, and just really expand the battery life and use case kind of usage space for this type of sensing. So these are mainly examples to drive the conversation about what could be done. Really, I'm interested to hear what reflects back from all of you as to what you're interested in doing with tech that lets you move more data for less power. So Jiva has some traction from private sector customers. We've also received some federal grants. We've worked with top tier tech companies, a major retailer, leading consumer packaged goods companies. We've also worked with NASA Armstrong Flight Research Center to explore some backscatter link budgeting in aircraft applications, and also to explore wireless time synchronization methods for these low power backscatter devices. We've also received NASA and NSF SBIRs. And, right now, I think Jiva is really at an interesting inflection point where we've crossed, a lot of the engineering hurdles needed to unlock the benefits of our tech. So we're really seeking, partners, investors, and folks who are interested to help us define what our next steps look like and come along this journey with us. So we'd love to hear your questions and certainly to follow up with any of you who are interested in this type of capability.
Awesome, Sarah. So I'll open the floor to questions, and we have one from John Richmond.
Hey, Aaron, that's cool technology. Is the backscatter device, is it an omnidirectional reflector? Is it steerable? How does that work?
Yeah, so there's actually nothing to prevent that from being a steerable beamforming style device. Today in our system, it's an omni reflector. So you can think of, the illumination signal is broadcast out by a base station. Our backscatter device is picking up a little chunk of that and is re-radiating it in a sort of omni way. So, the inherent advantage to omnidirectional radiation is, of course, that you don't have to worry about steering. There's a lot less complexity there. The disadvantage is that the link budgeting is a little bit more challenging in some scenarios. And also that, obviously, if you're re-radiating everywhere, there's an ability to kind of sniff or pick up that transmission from other locations. There is, it is worth mentioning that there are some very interesting properties of backscatter that are unique to backscatter that we believe can actually lead to a very interesting counter jamming capability as well, as in, the ability to essentially use a jamming signal as our illumination signal, and thereby achieve essentially some degree of immunity to that jamming. But that's different from sort of the privacy consideration.
That's cool stuff. I'd like to follow up with you.
Cool. Awesome. I'd love to.
I am using some information.
Okay, awesome. So next question we have is from Dan.
Yeah, so I had heard about you about 2 years back, and there was one particular application that I was kind of very curious about. I think you were trying to implement them with insulin pens so that medical devices can get a better value throughout their lifetime. So what happened to that line of products? Are you still pursuing it, or you have pivoted into the space-related products?
Yeah, we're not currently pursuing that line. I think, we haven't diverted entirely into space-related products at all. So we view ourselves as a general enabler of new systems and interesting solutions. We think there are great applications in space and also in other areas. So I would say that, that particular product you mentioned, the connected insulin pens, really was some work we did and a pilot project that we did with a large drug maker, drug manufacturing company, a big pharmaceutical company that was interested in exploring that, but ultimately they opted not to bring that tech into their system. It was really just an exploratory project at the time.
Got it. Thank you.
Certainly.
Okay, awesome. And for our last question, we have Craig.
Thanks so much. More of a comment than a question, but thanks for taking through that. I mean, as I mentioned in the intro, I'm a little different, I think. I don't know if there's any other Canadians on this panel here, but we have a couple of strong, it's a small company quickly getting into medium and will soon be large in the asset monitoring, mostly around engine monitoring and things like that are quite, they're quite connected into some military programs. They're doing some work with Pratt & Whitney. I think they would be interested, along with a few other stakeholders that I have, would be interested in learning more about what you have going on. You mentioned you were interested in partnerships. I just wanted to check first if that stopped at the border, or if it would be all right if and I believe your presentation's been shared with me, so if I'm okay to pass that along, I'd like to do that, and then maybe reach out to you and I and just have a one-on-one chat to get a better idea.
Would love to, and absolutely there's no border that we're stopping at here. I think we're happy to cross over and work with you and explore partnerships. I think to your point about asset monitoring and machine health monitoring, I think we view our tech as potentially an enabler for new types of AI systems that can generate deeper and better insights just by way of a much richer data set lent by something like what we can provide. If we can move more data for less power, that means a much richer data set to both train and perform inference on for systems that are really providing the end value of understanding where things are, what's going on, what the condition of a piece of equipment is, et cetera. So would love to explore anything in that space.
Excellent, and that's when it goes to the other big opportunity that immediately popped to mind is I'm supporting MDA in their work on the robotic arm for the Nuclear Gateway. It's going to be AI powered. It's going to be a lot of what you were talking about resonates with what they're looking for in solutions. So that would be another organization I'd want to flip your stuff over to. But I wasn't going to mention that together. I don't want to get your hopes up, right? But we'll see what they say.
Appreciate that. Yeah, would love to talk more. Sounds good.
Okay.
All right.
Awesome. So Aaron, thank you so much for pitching. Please leave your contact info in the chat as well, so that people, if they didn't get it down from now, want to reach out to you later, they could reach out. And also just see a couple people in the audience asked a couple questions, left a few comments. So just to alert you to that. And with that, we will move on to our next presentation, which is BitRip. And I'll let you take it away.
So I was going to unmute myself real quick. Appreciate it. All right, can everyone see my screen?
Yes.
Excellent. Okay, my name is Nicholas Dimitruk. I'm a former Marine who was in charge of over $250 million worth of logistics for a Harrier attack squadron. And I manage this with spreadsheets and pen and paper. And I think we can all agree that that is just not right. So I dreamed of an asset tracking system that was simple, something that could be learned literally in a matter of minutes, something that was lightweight, no printers, no scanners, no extra equipment that could weigh me down. Lastly, something that was universally accessible, a system that incorporates everyone, not just the master sergeant who holds all the keys to the castle inside an office, but a system that was accessible to the specialist right out of school, out on the field. a system that would enable me to walk up to any asset, whether it be an equipment, materials, tools, you name it, being able to walk up to it, scan it, and know everything about it. In 2012, there was no such system, and we all suffered. Missing equipment, long delays, the mission unnecessarily stalled. In 2023, there is such a system, and it's us. So here's a list of frequently asked questions that I can put up, and hopefully you have this on your person to read at a later time. But for me, that's it for the slides. What I'd like to do is just launch right into a demo.
Good afternoon. My name is Catherine Chapman, and I'm going to show you guys a little bit more about the BitRip app. So I'm on my phone here, and I'm going to share my screen, and you will be able to see the BitRip app is free to download and free to use today. So I'm just going to share how easy it is to edit and track BitRip anywhere. When you open the BitRip app, you are taken to a screen list of all of your existing assets. You can add a new asset and create new information.
We don't see the demo.
We're not seeing your screen. Can you share the screen?
Oh, can you hear me? You're not sharing my screen. Yeah, absolutely.
I was seeing it okay.
Let me go again. Oh, someone was seeing it.
Can you stop sharing yours?
Got it. Okay, you can share your screen now.
Great. If you are able to see my screen, please let me know.
Yeah, thanks.
We can see it.
Great. Thanks, guys. So when you open the BitRip app, you're seeing the list of all of your existing assets you've created. If you want to create a new asset, you tap the bottom right button, and we have these dynamic barcodes that you scan over. When you scan the code, it's sucking up some information about you, who you are, where you are within about 15 feet, and you can actually give your asset a name. Once you create it, you have a number of follow-up actions you can take. You can add any type of attachments, photos, text messages, PDFs, voice memos, even hyperlinks to websites. You can also share that information with other people on your team by adding it into a project. So if I add this bit into the inspection project, anybody who is part of that team is going to be able to see this information instantly, make updates and changes as needed. I can also upload images. So I'm going to take a picture of the code that I've just scanned, and those directly load onto the bit as well. So now anybody from anywhere can see and access this information if it's either shared with them or if they physically scan over the code. One of the new developments that we are working on, the BitRip team, is allowing for standardizing entry of information. So one example is different inspections that go on daily, weekly, and annually basis. We want to allow the entry of data in a very standardized and uniform format so that you're not just getting data, you're able to drive insights from that data. So the example I have here is a fire extinguisher form that you can fill out, submit, and we give you a PDF copy of exactly what that form response and answers were. So I'll turn it back over to Nick and Tom if they wanted to add anything else before we jump to questions.
And so as you can see, Catherine performed that demo immediately while on the road behind in the back of a car. And she's not driving, so no worries about that. What we want to really try and demonstrate is how simple the system is. And that's the secret sauce behind BitRip, is the ability for someone out in the field to be able to link assets within a matter of seconds, whether they're out in the desert or in the behind a moving vehicle. And so without further ado, I know we have only a few minutes. I'd love to take questions.
All right, great. Thank you so much, guys. I will open up the floor to questions. Yes, Dan.
Yeah, great presentation. Quick question. So I saw it was really easy to link something and track it. How easy it is to delink it? Because I'm sure you're going to have privacy concerns otherwise, right?
Yes. So we do have the ability to take what's on a bit and make it private. And then you can specify who gets to see that information, and anyone else who is outside that organization scans and they see a block message. But yes, you can delete all the data on the BitRip, and then anyone else who scans it won't see anything anymore.
Got it. Thank you.
Go ahead, Lisa.
Is there anything about this that lets you know if the asset's been moved? I mean, one of the things you said initially was we lose assets. So once you tag it and you know where it is there a way to figure out if it's moved?
Yes. So everyone seeing my screen? Okay.
Yes.
This is the Desktop Pro app. You can see I've got a few bits out there. If you look at live mode and you see that basically I know that those two things that Catherine just did have been scanned in the past 24 hours, and I can see their updated location, whether it be on the map or on satellite view. And so you can basically wake up every morning and say, hey, I want to look and see what's been scanned over the past, say, 12 hours. You hit return, and there we go. Asset 123 was scanned in the past 24 hours and is currently in Nashville. And so just go ahead, Adam.
Hey, I hate to ask a purely military question at this point, but is there anything against what you've got here that is an IL-4 or an IL-6 restricted? That means that I can't show where military parts are at any given time, specific to aircraft and or SOCOM?
Yeah, so we've had the request at times you can turn location off. So if someone scans it, they have location turned off, it won't update. So you can protect that if you want. But one of the major things we're looking to do, we've applied for a phase 2 SBIR. One of the big things we're looking to do is build an on-premise site where the data is secure, it's within your own systems. So there really isn't any, because right now we're operating on the Google Firebase, but we want to transition that to an on-premise data storage. So then they can have the full suite without having to worry about the location piece.
That's awesome. It sounds like it makes perfect sense. And I would actually kind of call Rudy out and see if, Rudy, if you know anybody at AFL-CMC that can apply this into the lifecycle standard in that process and find any source. I think this is great for large asset movement like that, especially when it's from base to base to base and it's within organizations. So thanks, Nick.
I appreciate it. Thank you.
Yeah, I agree. Usually I'll start nudging the rapid sustainment office guys over at AFL-CMC at Wright-Patt.
Great.
Okay,
and also, we do have we have another question also from Bare, and we have one more in the chat that we'll get to once all the panelists who can speak finish asking. So Bare.
Right, sure. Thank you. Great presentation. Just wondering about the barcode. Is it just the barcode or is it RFID? Do you have like a specific kind of a barcode, I guess, design for this?
Yeah, so we chose to build, essentially it's a QR code, what operates exactly like a QR code. So no active tracking, just passive scan tracking. So the location updates every time the barcode gets scanned. The big difference between us and QR code is QR code, you have to build in an office, you have to pre-configure it, you have to print it out, and then you have to match it and then go out into the field. Our proprietary barcode lets you link on the go. So there is no printing, there is no setup. You take any sticker, you stick it on the asset, scan, and it's being tracked immediately. So that's the big kind of edge we have over QR code. And because it's proprietary, it's also secure, so we can encrypt the data behind it and control it, whereas QR code is a bit of the wild, wild west.
All right, got it. Thank you.
Okay, great. And for the last question, we actually have Andrew Budai and from Air Force Futures. He wrote in the chat, is this app allowed to connect with Webflies, I think? What FedRAMP, FedLog, or does this exist outside of the impact level 2 and impact level 4 networks?
So the short answer is no. I mean, Google Firebase does have some FedRAMP compliancy, but the short answer is no, and that's kind of the big reason why we want to tackle those kind of things with a hopeful phase 2 SBIR. So that would be like essentially our number one effort.
Gotcha. Great. Okay. So with that, we're actually up for time, but thank you so much, Nick, and everybody else from your team.
Thank you, Brian. I'll leave my contact information in the chat. Appreciate it, Brian.
Yep. All right. Thanks. So with that, we will move on to our last presentation of the session, which is Sereniasat, where we have Tom George presenting.
All right. Can you see my screen, Brian?
Yes.
Okay. Well, hello, everyone. And my thanks to Deep Tech Showcase for this opportunity to present to you. Sereniasat is a certified minority-owned small business enterprise aimed at satisfying remote sensing data and information needs for the Department of Defense and commercial business verticals such as precision agriculture. We do have a Canadian footprint based in Montreal, Canada, and would love to connect to Craig McClellan. Let's see. Okay.
I'd love to too. I'm somewhat familiar. I know you exist. I'm looking to learn more though.
Oh, thank you, Craig. That's wonderful.
Well, yeah, let's connect directly.
All right. So what is the problem we are trying to solve? Although Earth observing satellites have been around for more than 50 years, Earth observation data has had negligible daily impact on global businesses. And this is primarily because global businesses do not currently have actionable information from space with the complexity and the latency necessary to match complex daily decisions. So data complexity literally means disparate and large amounts of multimodal sensor data. Complex big data, or so-called H-cube data, is important for minimizing collateral damage and especially missed events. And here H-cube means high spatial, temporal, and spectral resolution remote sensing data. Sereniasat specializes in the development of high-performance edge computing with advanced artificial intelligence and machine learning algorithms for reducing the time it takes to crunch through the big data and deliver actionable information to decision makers. So we solve the latency problem through high-performance edge computing on board the space satellites. And our IP lies primarily in deep learning algorithms that can rapidly distill Earth observation big data, as shown on the left, to provide robust, actionable information to decision makers. We have intentionally kept our core team small because we have spent the last 7 years of our existence proving our core value prop through $4 million of contract revenue, both from commercial and government contracts. I'm happy to say that not only have we proven our core value prop, but along the way, Sereniasat has built a large and comprehensive ecosystem of big and small commercial companies, prominent U.S. Government organizations such as NASA, USGS, and AFRL, and multiple academic institutions, which will all be required for ultimately implementing our H-cube solution. We are also very fortunate to have a strong group of industry-leading advisors. As you can see, we're addressing very large and highly scalable global markets using our unique combination of data complexity and low latency information delivery. Thus far, our initial beachhead markets lie in agriculture and defense. In both cases, we are pursuing a B2B subscription business model using multiple strategies, including recurring subscriptions, tiered subscriptions, pay-per-use, as well as bundling our offerings with our customers' products. The key business problem we are trying to address is the lack of actionable global satellite Earth observation data and information on a daily basis for multiple business verticals. Because of this lack of comprehensive and coordinated information, the current solutions have adopted an ad hoc, or rather disjointed, approach of collecting information that is mostly local and regional with a smattering of satellite data. Especially in these business verticals that are dependent on global Earth observation data, the holy grail of having daily data-driven decisions is not yet a reality. As you can imagine, if Sereniasat's H-cubed information becomes available, this will lead to significant improvements in management efficiency, cost savings, and high return on investment. In agriculture, early warning of crop stress is key, and this is where Sereniasat has successfully developed its agricultural application in close collaboration with Bayer Crop Science, a global agricultural company. For the US Air Force, our edge computing solution successfully detected a single flying airplane within a highly cluttered 100 square kilometer multispectral satellite scene in under 45 seconds. We've also successfully demonstrated this capability in space, flying on board the D-Orbit Ion spacecraft launched from a SpaceX Falcon 9 and detecting an airplane taking off from Hong Kong Airport. So as I said, in the 7 years of our existence, we have achieved a significant list of accomplishments, including large commercial and government contracts, such as $900,000 from Bayer Crop Science, $5.1 million from a NASA Invest Award, and 7 US Air Force SBIR awards, including a Space Pitch Day and Digital Pitch Day winning awards for de-risking our H-Cube high-performance edge computing solution. Our competition can be divided into data acquisition companies and data analytics companies. Saraniasat does both combined with the high-performance edge computing. And with regard to the ask, the United States Air Force runs a TAC-FI program that matches investor dollars 1-to-1 for a maximum of $1.9 million. And therefore, I'm hoping to find strategic DoD partners and investors who can help us to achieve our next milestone of an in-space demonstration of high-performance computing of Earth observation data. With that, I'd like to thank you once again for your time and attention, and I'm ready to take any questions. Thank you.
All right, and thank you so much, Tom. And with that, we'll move on to some of our questions. And first, we have Joe Epstein.
Hi, Tom. Great presentation. Really interested. First of all, is this pictures that you showed, is that delivered on the payload? Are you able to perform those sensor images and then send the data down, or is that processed on the ground still?
Oh, you mean for the space demonstration? Yeah, correct. For the space demonstration, the D-Orbit platform was just a space test platform, so it did not have a sensor associated with it. So we uploaded the, in this case, Maxar 8-band multispectral data to do the detection of the aircraft taking off.
Are you tied directly to a specific GPU processor, or are you working on developing are you making any inroads in processors that can operate in a space environment?
So we have identified a bunch of edge processors, and we've kind of shied away from the NVIDIA GPU type of processor because you have to write code specific to that processor, and thereby you lose the advantage of using legacy platforms, geospatial platforms such as it's now called NV5. It used to be L3Harris Geospatial's NV platform. With that, all of the 30, 40 years of development are basically lost when you have to rewrite that code from scratch. So what our preference has been is to use x86-based architectures where we can seamlessly port the algorithms from existing legacy platforms onto the edge computer. Thank you.
All right, thanks. And I also saw that Benjamin Zaytoun had a hand raised. Did you still have a question?
Yeah, Joe, you stole my thunder. So I think why do you decide to invest in your own 15 satellite constellation as opposed to partnering with existing providers like Sky Planet and many others that you mentioned?
We're actually pursuing a dual strategy. We are in conversations with BlackSky and Spire, looking at possible opportunities for hyperspectral. So essentially what we want to do is to move to a signature-based detection approach, and multispectral satellites, the current multispectral satellites such as Landsat or ESA don't quite cut it because you get a spectral point here and a spectral point there, And so to get a fingerprint of the phenomenon that you're trying to study, you need the depth of information that hyperspectral has. That's on the spectral axis. On the time axis, you need high temporal frequency in order to study dynamic events, especially if you want to be business relevant on a daily basis for agriculture in this case. And also, I assume DoD will benefit from that. So time, spectral, and spatial resolution are critical in order to get the signature in this three-dimensional domain to identify it positively and reduce the number of false positives and false negatives.
But so why do you want to build your own platform if you're a software company today?
We don't want to. We would much rather be the edge computing solution on a existing satellite. But as you know, in the space business, it's not a Henry Ford model yet. These satellites are customized to a specific mission. And to date, there isn't a constellation of hyperspectral satellites that are flying. But when they do, be more than happy to partner with the companies that are launching hyperspectral, high spatial resolution satellite for global Earth observation. I mean, our core IP rests in edge computing, of course, and that's where we would like to take it.
Great.
Does that answer your question? I'm sorry.
Yeah, thanks.
Okay.
All right, thank you so much, Tom. That was incredible, very great presentation. It was a pleasure to have you with us. And when as you stop sharing your screen and we move on, please just put your contact info into the chat so that people could reach out to you after if they'd like. And with that actually completes the first session. So we're going to move on to our second session, but to all the companies and panelists who were with us for only the first, thank you so much for joining us. Many of you are continuing on, so happy to have you continue with us. And if anybody only signed up for the first and still has time and is interested in staying and seeing some of the other company presentations, happy to have you on. Now, instead of having all of the companies, all of the panelists introduce themselves again like they did at the beginning of the presentation of the event, just because we're running a few minutes behind, what we'll do is we'll have companies present, and then during the Q&A, if it's your first time asking a question in this session, which is starting like from now on, just introduce yourself briefly before you ask the question, and then we'll do it that way. So with that, we will move on and have our first presentation, which is Precursor, and we have Clive to pitch.
Excellent, thank you. Let me share my screen. Okay. I think that works. Okay, let's get rid of that. Thanks everyone for being available today. Precursor SPC is a data analytics and decision support platform that uses machine learning nowcasting to deliver actionable information to commercial entities and the warfighter, centered around two very specific environmental conditions: natural disasters and the space weather environment. Let's see, what is nowcasting? Nowcasting is a forecasting technique that looks at current and near future events using only real-time data, not using models and not using historical data. So it gives you a very, very high fidelity, actual representation of the phenomenon or environment that you are looking at. What we do specifically is to combine space-based systems, multiple space-based systems, multiple ground-based systems, both radars and sensors, and combine that into a series of machine learning algorithms that uniquely determine in real time the environment of interest. Why is that important? Well, because we are moving into solar cycle 25. Solar cycle 25 has been significantly more active than predicted, resulting in dramatic changes in operations of space-based assets, degradation of orbits, impacts to missions for DoD, and ultimately impacts to ground and terrestrial operations that seemingly come as a surprise, or the model-based approach was unable to assess the impacts, thus resulting in significant economic loss, business revenue loss, and functionality loss. Specifically for space and for the warfighter, as well as for the commercial space environment, one of the most, if not the most important assessment that needs to be made in space is something called attribution. Was that particular event the result of a bad actor acting in a nefarious way, or was that a space weather event or anomaly, or was it both? Certainly that assessment has incredible consequences for a wide range of decisions that must be made in near real time, ranging from nuclear deterrence, regional conflict, all the way to commercial implications for operations both on the ground and in space. But it doesn't just stop there. It extends to tracking and communications for the aerospace industry. As we fly over the polar regions, which is highly perturbed environment, and during this solar cycle, high activity perturbations in the solar cycle, our aerospace industry is dramatically affected by not knowing in real time the changing conditions through which they are navigating. It extends to operations, primarily defensive and offensive operations in different theaters, whether it is over the locations of conflict today, or just planning for those conflicts. Man-made events provided conditions can dramatically change how we assess those particular situations. And then the last one shown here, probably one of the more important, if not most important, implications of having real-time decision-making capability based upon real-time, high-fidelity, high temporal, and high spatial resolution data. What Precursor has done under contract to U.S. Space Force, as well as under contract to commercial providers, is to provide the unique ability to, in real time and high fidelity, show the dynamic conditions of the space weather environment, but most importantly, how those dynamic conditions are in real time affecting missions and operations, whether that's spacecraft operations, radar tracking, communications, power utility management on the ground, GPS, positioning, again, for both commercial and government applications. This capability had never been done before in real time and in high fidelity. And that has led us to engaging in a number of commercial and government contracts with primarily U.S. and NATO-based organizations. What we're looking for today, and thank you for Deep Tech Showcase for allowing us to present, is just further customer engagement. The company has had significant revenue over the past year, and has engaged a number of customers in both the government side and commercial side, and we're just looking to expand that. So if what we are doing has or can impact and improve your operations, your missions, or your risk management, I would welcome the opportunity to speak with you. That's all.
All right, thank you, Clive. We have our first question so far from Bahare.
Hi, Clive. Thank you for the presentation. I'm Bahare Hajisai from BAE Systems. My question is, how much processing power do you need? Because you are processing, doing decision making, all those things are in real time. So how much? I'm just wondering about the processing power.
Our platform has been specifically architected to allow all of this capability to exist at the edge and on autonomous systems. In fact, that is one of the main use cases for our capability, is sitting on autonomous and edge-based systems.
Okay. Thank you.
Yep.
Okay, we do have time for one more question if anybody has one. Yeah, Gerald?
Yeah, thanks very much. So I'm curious to see, what's your differentiation from the other AI startups? Is it your data source for training your algorithm, or is it your the algorithm itself, or it's something else?
It's all of what you said plus more. We're taking in real-time data from a wide range of data sources, processing that in real time at the edge, and then using that or fusing that with existing assets and decision support systems to deliver real-time actionable information. No one else is doing that. All of the systems today are retrospective systems that forecast based on models that have high error bounds, and are not used in real-time decision making. It's a completely different paradigm.
Okay, yeah, thank you.
Okay. Great. I also see a question from Jeff. I mean, Jeff, did you want to say it out loud, or do you want me to read it?
No, yeah, just checking in. My recent assignment was with CIFSIG and CSPOG and Delphi, and I know they do a lot of internal weather reporting. Just curious if you've chatted with any technical or government SMEs there.
As a matter of fact, we have done a fair bit with Delta 5.
Okay,
so,
perfect.
So yes.
Well, you're good to go then. That sounds good.
Okay, great. So actually with that, we're out of time, but thank you so much, Clive, for joining us and presenting. And with you leaving, just please put your contact information in the chat so that people could know how to reach out to you, now that you're done sharing your screen. And with that, we will move on to our next presentation, which is Accelerium.
All right. Guys, can you hear me?
Yes.
Okay. Thank you, Brian.
Sure.
Let me know when you see my screen.
Yes, we see it.
Great. So thank you guys for the opportunity. We are a fabless semiconductor focused on reconfigurable compute for latency sensitive edge application and power efficiency applications. When you take a look at the defense and aerospace compute needs, they are really exploding. I mean, the new missions from NASA and the satellites launching and from different companies and what workloads are actually processed on the satellites are really changing and evolving. With all this going on, so you actually take a look at the workloads. There are really complex workloads where you need to do signal processing. Basically sensor fusion, AI, machine learning, communication from that perspective. And of course, for space, you need resilient compute, needs to be fault tolerance. You need to have multi-core, multi-cluster. And we have seen an emerging need for future-proof. I mean, it's not cheap to put satellites out there, and it's very useful to be able to upgrade the software and add more capabilities to what's been launched there from that perspective. And it's really critical to have power efficiency for these, and form factors are really key elements to the compute need within the defense and aerospace. We have seen, even from NASA reports that they talk about they need about 100x increase in compute capabilities for the same power utilization of what exists as solutions today. I mean, most of the solutions today really does not really even come close to the need from compute capabilities as well as power efficiency. If you take a look at today's space compute in general, is dominated from an accelerator perspective by what we call FPGAs and ASSPs from that perspective. So you would have a heterogeneous architecture with FPGA fabric to give you the flexibility, to give you some of the future proof, and to provide some of the software defined operations that you cannot really get out of the hard ASICs. And from that perspective, and you don't really get the performance out of like a general compute. These are really basically complex systems. Really, I mean, I don't have to tell anybody how big FPGAs are, how much power inefficient they are, and they're not really easy to develop from that perspective. So our approach is a completely different approach. We have to rethink the problem. So what we've developed is a reconfigurable compute platform that enables the hardware to adapt to the software from that perspective. So you have a homogeneous platform that gives you fault tolerant. It's all C programmable with ASIC swap C. It's actually more than 100 times higher compute density than FPGA, but still give you flow flexibility. It's 1 million times faster than reconfigurable FPGAs from a reconfigurability perspective. Even in accelerating workloads like an AI machine learning, we actually have a very powerful ability to accelerate AI machine learning. We're 50x lower power than GPUs. And, like people like NASA even recently awarded Sci5 to do, basically a SIMD vector processor to handle some of these acceleration on space compute. We're actually 50x better performance and power efficiency than the best in class right now from vector processors. So if you take a look at our, AP100 versus, basically the state-of-the-art RISC-V vector processor for some of the acceleration, and mainly most of the acceleration that's needed. I mean, it's either signal processing or like an AI machine learning. And, matrix of multiplication is a good indication of the capabilities that you can actually do for both actually in signal processing as well as in machine learning capabilities. And we provided also one used, basically algorithm FFT. And as you can see, we have about 50x improvement over state-of-the-art, vector processor or SIMD processor from that perspective, while we actually can provide, great performance and power efficiency. There are many target applications for our technology, from automotive to smart houses to factory floor, as well as in aerospace and defense. I won't go in details. We only have limited amount of time. When you take a look at the competitive landscape and also just being cognizant of time, our solution is from a compute density, again, it's about 100x than FPGAs. And from a power perspective is really highly power efficient from that perspective. So if you compare it from, AI machine learning compared to GPUs, is about 50x lower in power. The key thing is everything is in C. It's ISA compliant to RISC-V, so you don't really need to learn proprietary system. You can leverage all the open source. There's a a wealth of technology out there and wealth of people that they know the technology from that perspective. So we believe this is really the way to go from a future perspective. And of course, the focus on fault tolerance and resilient compute from that perspective. Our platform is basically provide that kind of capabilities for space compute. Just to quickly give you a traction and roadmap, the company was established in 2020 by basically experienced team from Broadcom, Qualcomm, and Intel. We had our FPGA prototype in 2021, and we created a model for our hardware, which we call the virtual platform, which is cycle basically accurate of our platform. So our customers already developing their software, they're benchmarking on that platform in anticipation of our silicon. We signed our first customer in 2022 for about $3 million, and we have an MOU with the Department of Air Force. In 2023, we'll be taping out our prototype chip. We'll sign our second customer for $2.5 million. We won a NASA, SDR direct to phase 2 for $1.25 million. And we actually, Space Defense, basically Space Development Agency. And we actually won a phase 1 for space compute with NASA. And 2024 will be the time where we'll have our production chip. Our asks today, we will be looking for investment as a Series A, about the time we get our prototype chip back, which will be middle of next year. We start talking to strategic from that perspective about that and some of the VCs. We're looking for, partnership. It's very important for us to have partnership with strategic corporates, partners, from that perspective, important for us. And we have opportunities to license our IP. It's the highest performance RISC-V compute solution, reconfigurable, that enables, great performance at a huge power efficiency from that perspective. The team, quickly, we have about 35 people. Again, myself is the CEO. I was a GM at Intel, and I was a senior VP at a publicly traded company, Mindspeed. Raheel, I was our founder and CEO. He actually basically was a VP at Qualcomm at Intel. He spearheaded all the software-defined modem at Qualcomm at Intel. We have a great team from great universities with great experience. We're a Silicon Catalyst company, and we have a great team of advisors. With that, finish my presentation. More than happy to answer any question you guys may have.
All right, thank you so much, Nasser. And with that, we'll open the floor up to questions. So if anybody has a question, raise your hand. And remember to introduce yourself if you haven't asked a question before in this session. And it looks like we do have a question from Dan.
Hi, I'm from BDF Ventures. We have a deep tech fund opening next year, and I'm also a tech scout with Alumni Ventures. So my quick question to you is this: are you using a block reuse, or are you using a subsystem reuse? Because without a subsystem reuse, I don't think you will be able to achieve the scale that you are talking about, right?
We have actually like an approach which is like really a trade secret. I would be more than willing to show you how we're actually doing this if we sign an NDA. But we have done something that no one actually have done that before. We actually, our microarchitecture can be configured based on the software without any influence from the customers who are writing the program. You can be a systolic machine, you can be a streaming machine, and you can be a vector machine. And we have micro configurability both at the micro and the macro level from that perspective. So it's something really innovative. We'll be more than happy to do a technical deep dive with your team, and we have numbers to back it out, and we have analysis to back it out. And again, we already advanced. We have an FPGA where we can actually measure the cycle counts, and we're already advanced in our chip. So we're already kind of like in TSMC 12 nanometers. So we actually have a ability to run actual code on the actual silicon and estimate the power and the performance using, Synopsys tools from that perspective. So we actually also have a proof. It's not, you don't just have to believe me, and we can show you these numbers.
But thank you. We'll be in touch.
Sure.
All right. Looks like we have another question from Mark.
Yes, hi. Mark Rosinski, General Dynamics Mission Systems. I think your slide said that you were planning production in 2024. Do you have foundries? Do you have agreements with any foundries established already?
Yes, actually, right now, as I said, we're at a test chip. We're targeting a test chip out with a 12 FFC with TSMC. But as part of our SDA project and the NASA, we need basically a trusted foundry also for some of the projects that we're doing for our compute. We're looking with global foundries in 22 FDX. And just between you and I mean, some of the activities that we have, we still try to finalize what could be the trusted foundry. I mean, some of our customers saying maybe they want to go to 5, but wait for Intel. So we might have 22, and then after that move to 5. So we already have a plan to go on the shuttle with TSMC in 12, and we're working on 22 FDX right now, Global Foundries for trusted fab for the other customers that we have.
Thank you. And are these going to be Class A chips? Are they going to be radiation hardened?
The project with the SDA, the first phase is to look at the microarchitecture and architecture by design, the changes needed from that perspective, and to use 22 FDX to understand what's the impact to performance and power. And there will be a phase 3 from that perspective to end up being in a rad hardened process and basically rad hardened also by design from that perspective. And we have lock steps, processor designs, and we have cluster isolation plus other factors that we're working with our customers to make sure that we meet all the requirements that they need.
Very good. Thank you very much.
Of course, and we'll be more than happy. Actually, like if you want, like offline, you send me an email. We'll be more than happy to do a more deep presentation for you and your team.
Yes, I'd like to get your email, please. Thank you.
Of course, it's in here, but I can put in the also.
Yeah.
I see it. Thank you.
Yes, Nasser at Accelerium.com. Yes.
Yeah, awesome. Thank you so much, Nasser. That was great. And actually, with that, we're up for time. I do recommend you do add your email to the chat, as you said. Sure. you would do. And with that, we will move on to our next presentation, which is Intergalactic.
Sure.
And we have Nick.
Hey, Brian. Hey, everybody.
Hey.
Just going to share my screen here. Okay. Can you see it all right?
Yes.
Great. All right. Hello, everyone. My name is Nick Kaiser, the Chief Technology Officer with Intergalactic. Thanks for taking the time to stop in today. So, a little background on the company, maybe a little bit of change of pace from some of the other companies where we help support a lot of the different technologies that are being talked about here. But really, our whole background is in thermal management of all different types, but specifically aerospace. And really, the company was founded to solve some of the constraining problems that have popped up. I think, anyone that's working in almost any field, technical field, is experiencing challenges with increasing heat loads and more exotic and dense electronics, higher thermal densities. Certainly, space brings a whole host of unique thermal challenges that make things even more difficult. But we formed the company to develop new technologies to solve a lot of the problems that have been popping up. So we got our start in defense aviation. That's where we kind of started out, and it's really created a lot of our core business, supporting Air Force platforms and other things that are flying fast with new sensors and electronics and things like that, packaging them into smaller things, trying to increase capabilities of existing platforms or develop new platforms. Since then, we've kind of expanded out into other sectors. We do a little bit of ground-based equipment and naval things, but the other focus area for us is space. So excited to be talking to this group today. It's a little bit of a newer area for us, but some of our previously developed technology and new things that we're working on are very relevant to the space. A few examples of things that we're either dabbling in already or interested in, or launch motors or rocket motors for launch vehicles, habitation like Eclipse systems, whether it's on a space station or lunar habitation and beyond. some of the high energy computing that I heard a little bit about in one of the other presentations on satellites or other vehicles, propulsion, small sats, really, you name it. Anywhere there's a thermal problem out there in space, we're either currently developing stuff or have some other things coming down the line. And the other big problem, and one of the reasons the company was founded in the first place, is the thermal world really hasn't had a whole lot of development or innovation in the past 50 plus years. A lot of the solutions you see are existing technologies from aviation that kind of got shoehorned or scaled up, and it's kind of gotten to a point where you have large, unreliable, bulky, heavy systems that just aren't adequate for what's happening. So we're trying to help solve some of those problems. Like I said earlier, we got our start in defense aviation, kind of make a wide variety of active cooling systems for that. And some of that's applicable to high power systems in space, although obviously not everything. And there's a desire to cut down on complexity, but we've got a lot of background in vapor cycle systems, liquid systems, heat exchangers, all the components that go into that kind of equipment. And some of that is applicable, which I'll show here in a second. So I'll kind of start out with one of our core pieces of technology for our ground systems, which does have applicability in space as well. And that's what's called a microtube heat exchanger. So this is effectively a bundle of very, very small diameter tubes that provides heat exchange performance in a package that's 1/2 to 1/3 the size and weight of the next best available technology. So it's really a step change in performance and size. It's also more robust, has some other benefits as well that I'm happy to talk about offline. And this finds a home in space in a few places. One, rocket motors. So there's some interesting heat exchanger applications in rocket motors that, got the example there on the right that, we've had some interest in, where you've got tons of these things and you can really pull out a lot of weight and provide a pretty robust solution for an extreme environment. And then also in Eclipse systems, and there's some ways to take this and leverage it into radiators and stuff like that. But this has been really a foundational piece of technology for us, and there are a few places that we're looking to put it into space. And then here, there's a lot going on, but a few different things that we're working on. There's cold plates all over the place, and any kind of electronics cooling or other places as well. Pretty much all of them are just hunks of aluminum with channels milled out of them. We are developing a composite cold plate, which sounds crazy, but there's ways to take some of the new composite materials and aligning some of the properties to get conduction that will work and provide equivalent or better thermal performance in a package that's much lighter. So you can really pull a lot of mass out with that piece of technology, and that's got applicability all over the place. We're working on pump two phase, which is a existing technology, but it has its own challenges when you're going into we've been doing some work in high G aviation environments, but even more challenging is zero G of space. So we've been doing some work there, which has applicability for, one example are rovers on the moon, but anything that's got loads and you need to have a system where you need to move fluid around that's got really wide ranges of temperature, high loads, things like that. Phase change thermal capacitors, again, another technology where there's been some work done, but we're trying to push this off into more extreme environments, and also leverage our microtube technology in that for a capacitor has a higher, faster charge and discharge rate. But that can be used for anywhere where there's transient loads. One area that there's been some interest is anywhere we have a day-night cycle, so some satellites or lunar applications where sometimes you're in the sun and sometimes you're in the dark, and you want to balance that out. Some have called it a thermal switch. So that's another thing that we're working on. And lastly is, where there is a desire to stay away from active systems in space for obvious reasons, but sometimes the loads are getting so high that we have to figure out how to do that. So we do have traditional vapor cycle systems that will work in zero G. They don't have any oil or things like that, along with some other heat exchanger and pump systems when we need to use them. Just real quick.
Just letting you know it's a 1-minute warning.
Okay, cool. Thanks, Brian. I'm almost done. Real quick, our team, myself here, but there's a couple of folks that have come from the space world. David Walker, our CFO, he was at Lockheed out in Colorado in their space group for quite a long time. Ben Bryan, he was at Lockheed and NASA as well. So we've been leaning on, especially Ben, a lot of his experience. And some of you may even know him. He's a well-known fellow, but we got a couple guys that have some pretty deep experience in the space. And really, we're looking for a wide range of things. We have a couple customers in the space now, some of the big primes, but certainly interested in anyone else that might want to partner up as a customer or, to deploy or develop this technology, or also support us in any potential BIR or other grant activity. So I think that's it. All right, yeah. So thank you. Happy to field any questions now, or got my contact information here. Happy to, anyone to reach out.
All right. Thank you so much, Nick. I'll open the floor to questions. If anybody has a question, hasn't asked before the session, just introduce yourself prior and just raise your hand, and we'll call on you one by one for the hands raised. Dan?
Hi. Quick question. Are you already talking to the Airflows and the Pipistrels of the world for the electric planes, or you're still about to do that?
Yeah, we're talking to many of the electric and eVTOL aircraft companies. In fact, we won a major contract with one of them that we'll be releasing some news on soon. But yeah, we've seen a lot of interest from that space.
Thank you.
Sure, we have time for one more question if anybody has one. Gerald.
Hi, this is Gerald from GC Ventures. So you talk about several material solutions here as the thermal management tools. So which one is your core technology? So what is your core technology about?
Our core technology is really microtube heat exchangers, which are a metal-based platform for now, stainless steel. Although we are looking at some polymer and composite solutions as well. And then, as far as material stuff, probably the most interesting thing we have going on are the composite cold plates.
Gotcha. Yeah. Okay. The reason I ask is we do have some portfolio companies in the composite world, so they have some special features. Yeah, we can take it offline, and I will send an email to follow up.
Yeah, that'd be great.
Great.
Awesome. With that, we're actually out of time. But Nick, thank you so much for pitching Intergalactic. Just put your email in the chat once you're stop sharing the screen and people can't see your contact info anymore. And with that, we'll move on to our final presentation, which is Kayhan Space.
Let's see. Can you see that?
Yes.
Perfect. Awesome. Well, I'm Andrew Melcher. I'm the senior program manager at Kayhan Space. Run our government contracts and government business development. Spent the prior 7 years of my life at SEAL Team 7, where I got brought over to join this team. Co-founders are Dr. Siamak Haysar, who has a PhD in aerospace engineering and prior work at NASA, JPL, and Blue Canyon Technologies. And Araz Faizi, who has background in IT and cybersecurity, and together they are bringing next-generation computing power to space operations through Kayhan. They've assembled a team with deep expertise, especially in space, supporting NASA, JPL, and national security satellites. So we know what satellite operators want and need and are looking for, and we know how to answer their questions. Additionally, they assembled a board of advisors that have deep expertise in the commercial space industry and strong government relations as well. So through just across 2 years, short 2 years, Kayhan Space released the first of kind autonomous satellite collision avoidance system through Pathfinder 2.0. And then Pathfinder 3.0, soon to be released, will be the world's first space traffic coordination platform. Additionally, we have contracts with the DoD, NASA, and Office of Space Commerce, and we are well positioned for future initiatives. So why space? Well, space supports, everyday life on Earth here, air travel, navigation, GPS, communications, national defense, and agriculture, just to name a few. So with all this upside, these large industries and lowering launch costs, there has been an exponential growth within the commercial space industry. So since the dawn of the space age, we have launched approximately 10,000 satellites into orbit, creating approximately 1 million debris objects from those satellites. Across the next 10 years, those numbers are expected to increase tenfold. As an example, today, a constellation of 100 satellites in a busy orbit, the operator is going to experience approximately 63,000 potential collisions per month. So this shifts the focus of the operator from their respective business case to now just protecting their satellite. So when an operator has a potential collision, they receive a conjunction data message in the form of a bunch of generic emails that they have to sort through and find the high-risk event. Then, through disaggregated and slow processes, they need to figure out how to coordinate with other operators and figure out how to deconflict their assets. Additionally, there are no really rules of the road for this deconfliction process. So, meet Pathfinder, the world's first commercial space traffic coordination platform. Through the autonomous processes and streamlining of deconfliction and coordination for satellite operators, KHON is bringing speed and faster response times to satellite operators. Through these easy to set rule-based systems, we believe KHON will be the standard for space traffic coordination and deconfliction between operators. Additionally, as more operators start to use the system, we are able to ingest more data. As more data is ingested, the data becomes higher fidelity and more useful, essentially adding value to the systems of operators. In essence, we're creating a network for satellite operators. This network will allow operators to get access to further fidelity or higher fidelity data, and all of this data is built upon a powerful coordination and deconfliction system brought by KHON through Pathfinder. Currently, Pathfinder services over 20 satellite operators, including Space Delta IV, and across them over 500 satellites today. Some of our current capabilities, in addition to the ground-based satellite collision avoidance and space traffic coordination, as already discussed, we also provide rapid launch conjunction assessment, rapid high-fidelity orbit propagation, high-fidelity orbit determination, data curation and validation, as well as rendezvous and proximity operation safety. Expanding upon those capabilities in the future, we plan to have onboard autonomous collision avoidance, onboard high-fidelity orbit determination, satellite evasion and stealth operation support, flight operations suite, multi-target tracking and custody, atmospheric drag model improvement, and anomaly detection. And with that, are there any questions?
Great, thanks, Andrew. Okay, so we'll open the floor to questions. If you have a question, please raise your hand. This is the last company, so especially if you didn't ask a question yet throughout the event, now's your last chance if you want to ask a question. So just let people find the raise hand button, and then you can ask away. Yes, Dan.
Hi. We had actually invested in Capella Space, so I know a lot about what you guys are doing. And I think Ares was there at TechCrunch Disrupt 2022, so I have seen the presentation there as well. Quick question. So for the LEOs and the MEOs, is the procedure any different? And how are the product offerings for geosynchronous versus polar satellites?
Yeah, I can take that question. Aras Casey here, co-founder and CTO. So let me repeat the question back. So are you asking about the difference between LEO and GEO?
Yeah, no, LEO and MEO, like when they're being launched, they're in different things that you're offering for those two satellite providers.
Yeah, no, great question. So obviously the biggest problem today is in LEO. As you know, there are certain orbits that are extremely popular, and we have a lot of operators that are launching into those orbits and operating in close proximity. So our biggest focus is on LEO right now. However, we have GEO customers. From an asteroid mammoth perspective, it doesn't really matter which orbit you're in. Our recommendations, our maneuver generation and maneuver recommendations work perfectly for all three orbital regimes. However, the space traffic coordination problem today and in the future will be, most pronounced in LEO, and that's why we are investing pretty heavily in the LEO kind of network that we're creating. I think we have to get the numbers right. Somewhere between 20 to 25 operators in low Earth orbit that are using Pathfinder today.
Thank you.
Sure. We have time for another question if anybody has one. I see some actually questions in the chat. Somebody asked what your primary sensors are and differentiated analytical tools.
Yeah, let me answer the sensor question first. I don't know if I see this as an answer question, but we have made the decision not to own or operate any sensors. So main source of data for us today is US Space Command's high fidelity, high accuracy SP catalog, which includes about 30 to 40,000 operational satellites, defunct satellites, and orbital debris in it. We overlay that with the publicly available, published owner-operator ephemerides. So, for example, SpaceX publicly publishes theirs. And on top of that, we add our own customers' GPS-based trajectories, which makes it one of the most precise catalogs available out there.
Gotcha. Thanks. And then somebody else was wondering what stealth operation means.
Got it. So this is and I believe this is coming from the last slide. So this is a R&D project that we're working on, and this is, you have stealth airplanes. We have designed certain algorithms that allow national interest and national security assets to be able to hide from tracking based on, I'm trying to see how much I can share. So based on the knowledge of where the adversary's sensors are, this algorithm can help satellite operators pretty much, or satellites pretty much get lost between other satellites. So it's, it allows national security assets to hide from adversary tracking.
Well, that's really cool. And if nobody else from the panel has any more questions, we could finish up with the last question, it seems, from the audience that I see, which is someone asking if you anticipate growing your business into a communications network.
It's already grown into a communication network. Actually, in fact, today we released Pathfinder 3.0, third version of our product, and that enables operator to operator, not only just human language communication, but also automatic computer level communication. So if I want to describe it very quickly, is that as a satellite operator, you can set a policy how I'm going to deconflict with other operators if we have a high risk event. And you can build certain rules that will automatically take effect without, without getting any manual input. But also it allows operators to talk to each other. And the idea is that, the more operators you have that are on this platform, the more valuable it gets for the next operator to join the network. And as I mentioned, we have over 20 operators in LEO that are using it today. And our goal is to get it to 50 in the next 6 months.
Awesome. It's really cool. So with that, we're actually out of time. But if you want to put your contact info in the chat for the little time we have left of this event, but just so people could see your contact info now that your screen stopped sharing, please feel free to do that. And with that, thank you so much to everybody who pitched, all the wonderful companies who pitched. Your technologies were amazing. Thank you everybody on the panel who were with us in either session or both sessions for sticking through the event, contributing to the conversation. We really appreciate every time you join us for these events. And thank you everybody in the audience who joined us throughout this event. We really love when you join and also participate in the comments. So with that, that concludes our event. Just want to mention or give a brief shout out to our upcoming events again. So we have, we're collaborating with GC Ventures on November 14th. We have a decarbonization showcase. And on November 29th, we have a Future of Computing showcase from Deep Tech Showcase. And if you want more details about those, just check out deeptechshowcase.com. Look at our upcoming events, and you could get some registration details, and you could register. And as for recordings, I anticipate sending the recording of this out early next week. So in case you're wondering, you should be getting that then. And again, thank you so much, everybody. It was really a pleasure to have everybody with us. So have a great rest of your day. And hopefully we'll see you soon in another event.